Swastiastu. Thank you for the time. My name is Nyoman Trifabiolantini. The student number is 2013011006. I'm from 4B class. I will talk about projection. Projection is the transformation points and line from one plane to another by connecting the corresponding points in two planes with parallel lines. And there are two types of projection in the vector discussion, namely scalar projection and orthogonal projection. The first, scalar projection. We have two vector is vector A and vector B with an angle alpha and make a perpendicular line of vector A and vector B. We call is the vector C. Non-vector C is the scalar projection of vector A on vector B. The first, cos alpha equal non-vector C defined by non-vector A. Non-vector A times cos alpha equal non-vector C. Non-vector C equal non-vector A times cos alpha. Non-vector C equal non-vector A times vector A dot vector B defined by non-vector A times non-vector B. Vector C, non-vector C equal vector A dot vector B defined by non-vector B. And so conclusion of scalar projection of vector A on vector B is vector A dot vector B defined by non-vector B. And scalar projection of vector B on vector A is vector A dot vector B defined by non-vector A. Next is orthogonal vector projection. We have three vector is vector A, vector B, vector C, and angle alpha. Vector C is a orthogonal vector projection. Vector C equal non-vector C times unit vector B. Unit vector B is vector B defined by non-vector B. And vector C equal that we got before. Non-vector C is vector A dot vector B defined by non-vector B times vector B defined by non-vector B. Vector C equal vector A dot vector B defined by non-vector B square times vector B. So conclusion, orthogonal vector projection of vector A on vector B is vector A dot vector B defined by norm vector B square times vector B. And orthogonal vector projection of vector B on vector A is vector A dot vector B defined by norm vector A square times vector A. The next is vector in the 3 dimension. Vector in the 3 dimension is a vector that has 3 axes, x, y, and z. The axis x is a line where a point has coordinate x, 0, 0, and axis y is a line where a point has coordinate 0, y, 0, and axis z, a line where a point has coordinate 0, 0, 0. The next is non-vector in the 3 dimension. Vector A equal x, y, z. Non-vector A equal square root x square plus y square plus z square. The example, vector A equal -1, 3, 5. The non-vector A equal square root -1 square plus 3 square plus 5 square equal square root 1 plus 9 plus 25 equal square root 35. The next is position vector in the 3 dimension. Point position vector P is the vector that start point O is 0, 0, 0, and at point P, x, y, z. The next is unit vector in the vector 3 dimension. Unit vector is a vector whose norm is 1. I equal 1, 0, 0. J equal 0, 1, 0. Chi equal 0, 0, 1. The unit vector of vector A is vector A defined by norm vector A. The example, unit vector of vector A is a vector A equal 1, -2, 2. The first norm vector A equal square root 1 square plus -2 square plus 2 square equal square root 1 plus 4 equal 3. The unit vector of vector A equal 1, -2. Mana sih? Okay, the unit vector of vector A equal 1, -2, 2 divided by 3. And the unit vector of vector A equal 1/3, negative 2/3 and 2/3. And the equation from the unit vector of vector A equal 1/3 I minus 2/3 J plus 2/3 K. Thank you for your attention. I hope it's useful. Om Santi, Santi, Santi Om.